thing you have been learning and you have been practicing on the topics that we have already discussed, so that based upon that I can understand like how's your learning pace right now, and if there's any gaps remaining, I will try to cover them in the upcoming sessions. So that is it. So you can just demonstrate your screen and show, and later we will be going to the machine learning advanced models in the next few classes. Yeah, please go ahead.
So can you see my screens now?
Yeah.
Can you see my screen? Can you see the personality disorder data set I'm working on?
Yes, I can see your Google Colab notebook. So yeah, you can just go ahead from the start and just tell me like how and what have you implemented in this.
All right. Just 1 second. Just gonna need to. So this house prices one. What have I done? What have I done? What have I done? Yeah, yeah. These. So I've got a question.
Yeah.
I've got a question. So for this house prices, if you look at it now, so because what you've just taught me is regression, and I want to kind of work on these house prices that I've done in the past. So let's say this is the house prices, these are all of the features up onto so um these are the nulls, and this is me looking at the data type, looking at the number of nulls, and so this is Seaborn, and I'm using these to kind of to look at the missing values, look at where there are missing values.
Hmm.
Um, yeah. So this is me filling the missing values with the median. So I think I've learned another skills to kind of fix the missing values whereby I'm using the values of the other data points. I'm kind of training on the values on the other data points to predict what the missing values are. I can use that in the future.
Right.
That's is that okay?
Yeah, yeah, definitely fine.
Say that again.
Yeah, it's okay, fine to use, but
Yeah.
just
So I
make
think I've
sure.
learned that part.
Yeah, right. Just make sure that while you
Say
are
that again.
filling, yeah, so just make sure that while you are filling these values with the mean, median, just try to see that your distribution don't get skewed. Suppose you are using median here, right? So just make sure that
Yeah.
it won't affect your data much, right? Like basically, what I'm trying to say is
Okay.
just try to see like whether mode will work better, or like, because if you replace all the null values with median, so it may affect
Yeah.
the other columns, right? Or the basically the
Yeah.
it's other dependency on this columns. So just you have to check whether all the other
Yeah.
correlated features or the other correlated columns are affecting when you are doing this data manipulation. So just keep in mind that,
Okay.
and just try to explore more other
Yeah.
techniques than mean median mode. So there are some other uh hello.
Hello.
Yeah, can you hear me now? I think network is.
Yeah, I think I lost you for a bit.
I'm not able to
I
see
can hear you now.
screen. Yeah, I'm not able
Can
to.
you see my screen?
No, yeah, now I can see your screen. Yeah, so that is what I was
Okay.
telling. Like, just try to see other techniques other than mean median mode also, right? How you can replace the null values
Yeah.
with other techniques as well. Like, there are um some more techniques where you can replace those null values with, right? You just try to explore them. That will give you a better understanding of like how you can place the missing values without compromising your accuracy, or without compromising your uh, loss of information.
Yes.
There are some other.
Yeah. So I've kind of inputted the missing value. So I kind of filtered the data. So my question is, now that I've got this regression now, and I'm looking to, let's say, for example, I kind of do all the feature engineering, which, so how do I know if this, how do I know I'm supposed to use a linear regression here or it is polynomial? Because if I'm going to do this, I'm going to be looking at how linear each of this feature is to the target. Is that right?
Right. So see, basically, like which model you use completely depends upon the type of target, or like completely depends upon the data that you have and the target values that you have.
Yeah,
Suppose here you have the regression, right? The price. So the price is your predictory model, the predictive feature, right? That is
yeah,
a label that you want to predict.
yeah,
This is regression, right? Basically, this is a continuous
yeah,
value that can range
yeah,
anything, right? It is not a
yeah,
discrete value.
yeah,
If it is discrete, it will be a
yeah,
classification problem. Then the classification model will be used, like
yeah.
logistic regression or
Logistic.
decision trees, right? But
Yeah,
since like this is a
yeah,
regression problem, like
yeah,
mostly linear regression and support vector regressor, right? So these models will be used. Now again, like which of the from out of these regression model, which of them work well is something that you need to test most of the time by
yeah.
using these cross validation and by testing it, like which of them give better accuracy. But again, most of the time, start with the simpler model like linear regression and these, and then you will try, then you will get the idea with the accuracy metrics, right? As we have discussed, like mean, absolute mean error, and right, squared mean error, mean squared error, right?
Yeah,
So though they will give
yeah,
a broad idea of like how you should choose the model, which model to choose.
I understand. So that means that I will just have to continue using linear regression, the polynomial, and every other ones
Yeah.
and see the best one
Yes. Right.
out of everything.
Right. And also we will go through some of the other algorithms like this support vector machines, naive Bayes, perceptrons, neural networks. So then you will get a better understanding of like how other algorithms also work, and you can then compare and see like which of them give the better accuracy.
So I think I've made a mistake. Yeah. So yeah, that I've kind of used correlation to kind of see for feature selection. Was that right or wrong? Because looking at this now, if I'm going to do feature selection, I can see even square footage, lot size are not really much correlated to price because they're zero point 0.1 sort of. So if you're looking at price for square footage minus, and this one for lot size is even 1.0.
So can you tell me like what you can tell from this matrix? Like,
Yeah, what I can tell from this metrics is looking at the correlation between square footage, lot size, and price. Just looking at price being on this price to price is 1.0. Obviously, it's
right.
correlated because they're the same picture. However, price to square footage is 0.12, and that means it's a bit correlated. But price to lot size, they're not even correlated, 0.02. So there's more correlation between square footage and price than lot size.
Yeah, that's it. That's it. Exactly. So you guessed it right. So this is how it works. So now you know that square footage is more related than lot size. So lot size is not that important in the price. Square
Yeah,
footage is more important.
yeah. So I kind of so what I just want to understand now is I'm trying to look for what you gave me the last time. Just 1 second. I'm just trying to look for that now. I should have it here. Let me just look at. I'm just gonna. So my question is how this really. So yeah, exactly. So this is where my question is coming into. So now let's say I've got all of these. So I've done all of these. of so for example now I was looking at outliers. I'm struggling to identify, is it that these are the outliers for each of these features?
Right, right. So these are
Hello.
features, townhouse and all those, and those are the outlier points, data points.
Say that again.
Yes, they are the outliers of those features. So like for a townhouse, right? Townhouse, third column,
Yeah.
or the single
So
family.
anything outside of this place are all outliers.
Yes,
Yeah.
yes, yes. So can you explain me this box plot?
Yeah. So this is a box plot showing the how close each data point is to the 50% percentile. So I think this is the 50% percentile, yeah.
Okay.
And anything within this place and this place
So can you tell me
is
like
within.
which line these lines are what? Like can you tell me like the definition of each line?
Sorry, can you say that again?
Can you tell me like what these each lines are? Like so center one is the 50%, 50% time. And what are the top
Yeah.
bottom?
Yeah. That's 75%. And this is 25%.
Uh, no, actually. So these are the decision boundary, right? Upper bound and lower bound. So these are the, if you will check again, it is the something times multiplied by upper bound, then you get the upper bound. So if you will get again to this concept, you will find that there is some values like 1.5 mostly. That is multiplied to the upper bound, then you get that decision boundary. And any point above that is an outlier. Okay. So just go through that
I'm,
again,
I'm
guys, like
struggling to hear you clearly. You're
mathematics.
breaking up.
Hello.
So does that, sorry, you're breaking up, but yeah, I can hear you.
Yeah, so we have discussed that in the month first, in like initial weeks. I would ask you to go through
Yeah.
that this concept again. You will get the mathematics. So basically, these lines are 1.5 times upper bound, right? So it will give you that value. So
Yeah.
just check it again. We'll
Yeah.
get better understanding.
Yeah, I understand it. I just want to confirm that all of this means that these features as outliers. That's just what I want to kind of confirm.
Yeah, that is the outputs.
And also there are outliers in these ones also
Hmm.
in the house. So I did the calculation to kind of,
Yeah,
those
so
are
this is
what you're
exact.
trying to explain,
Yeah,
right?
yeah, right. So this is the 1.5 times IQR, right? Just give you the lower bound. And that is
Yeah.
subtract that with Q1. So this is the mathematics. So just try to look it through it again.
Yeah.
And
So
there's
I'm
an
going to work on the
have you
outliers.
missed that?
Say that again.
There's an assignment. Have you missed that? Replace the outliers.
Yeah, no, I've not done it. I've not done it.
Okay, so I want you to
So
yeah.
my question is, these outliers, how do I actually replace them? Because obviously it's going to be expected for outliers to be in this data sets because it's looking at price. So that's where my question is.
So you have to
How do I replace
identify.
the outlier?
You have to identify. See the threshold. There is the threshold, right? Outlier threshold.
Yeah, yeah,
Bottom. And now, yeah, this is the threshold, right? And any
yeah.
value that is above this value and below this value, you will separate those rows out. And those rows are your outlier rows.
So what am I going to do to those rows?
Though, so those rows you will be changing them or you will be removing them or you will be just changing these values. If there are some other information, you will be changing just these value. If this is the only value, then you will completely replace these rows. Basically, you will
So I can
not,
replace those rows with the mean
yeah,
price.
right, mean price or something like that. But again, you won't let these value go into the model because this will affect
Okay.
affect the training.
So that brings my question that do I check for this outlier in every feature or only the target feature?
And every feature.
Every feature,
Yeah.
especially the one that has got high standard deviation.
Yeah, this you have to do in every feature.
Wow. All right. So let's say maybe I've gone on through every feature. I've kind of so now looking at this my data set now. So my data set is ready for training,
Hmm.
but though I've not done the outlier, so it could be, but I would say it's ready for training. So this date, so for these 1940s, 1950s, I can use it. I can instead of that do cross validation to kind of no, sorry, time series splits. So I'm
Hmm.
going to split by the previous date if I want to kind of if I want to bring the date into the model.
Hmm.
Is that right?
Say again.
Yeah. So if I want to bring the date into the model, that means I'm going to be splitting by the date, by
Hmm.
this decade or by date.
Hmm.
So now that my so now that as you can see, it seems like my model is ready for, but
Yeah,
obviously,
the decade is in the textual format. That is not in the numerical, right? There is S value. You have to change that.
yeah.
That S needs to be
Which
removed. It
one?
needs to be in numerical format. This S in the decade. This
X in
1970
where?
S. In decade. Yes.
Oh yeah, yeah.
So this needs to be
Okay,
handled.
so I'm gonna need to take off the S. Yeah, yeah, yeah. At some point, I'll take off the S. So when I'm ready, then I'm just going to split by X and Y. Then I'll try polynomial. So once I no, I'm going to try just normal regression, or I could. So cross validation. How does cross validation now work? Is cross validation like an evaluation metric, or it's like a splitting metric, or it's like a training metric? I'm trying to understand because I understand that cross validation
Yeah,
maybe
just
instead of me
open its
training.
documentation. Just search on Google cross validation. You will find some resources. Just search it. Just I want to show you like how.
Yeah, I was
Yeah.
okay on Google. Just 1 second. I can't see my screen very well because of this thing. I'm trying to take this thing off. It's not gonna let me take it. Okay. I understand. I've kind of looked at the theory, but I think if you explain it to me in terms of instead of is cross validation replacing other evaluation metric or it's replacing the splitting metric, or I'm trying to understand. Is a technique for evaluating okay machine learning models. Hello, can you hear me?
Yeah. So you read this, I think you will get an
So
idea.
that say that
See,
again.
so you just read this, I think you will get a better idea now that if you
Yeah.
cross validation, basically you split your data and try to do this training on different subsets. So for each subset, you will just change the parameter and hyperparameter and see which hyperparameter works the best, right? So that is how you choose hyperparameters as well, like in cross validation. So cross validation
So
is
what I'm going to
basically
ask you.
just getting the subsets of your bigger data and training on that. So you can compare its accuracy as well.
So what I'm saying is, with cross validation, once I've done cross validation, then I don't need to split my data. I don't need to do train test splits anymore, and I don't need to train the data anymore or use RSE or RAE evaluation anymore. Is that what you mean?
Yeah.
Cross validation replaces all of those things.
Hmm.
Is that what you mean? Is that what cross validation is? Or if after cross validation, then I still have to do evaluation metric like RSE and the rest?
Yes. So RAC are basically your evaluation. RAC comes later. So cross validation is just a technique. RAC will be help. So this RMSE and all those techniques will tell you the score, right? They will give you score. Cross validation will not give you the score. Cross validation is just a technique, right? Where you just divide your data set into some smaller subsets, right? Are you getting the difference?
Yeah, so why do we do cross-validation if it's not going to give us the score of our model?
So basically, it is you just take different subsets, right? Just
Yeah.
see the benefits, the key benefits, reduce overfitting, right? And scroll more. So it will tell you like why you do cross validation. If you just read the key benefits, right? Just why I'm not explaining you, why I'm asking you to read, because we have already gone through this concept, right? And this is what I gave you to understand. So that is what I'm trying you
Yeah.
to approach.
That's fine. So for this poly, polynomial regression, so let's say some of our features, some of the features we've got here, if we compare it to price, is having the kind of bend. So for example, let's say we are comparing all of the features to see if they're all linear or if there's any polynomial feature to the target one. So let's say there's a particular one that is polynomial to the target that has two or three bends to the target feature. Are you going to say we take only that, we train the model on only that against the target feature and we exclude the remaining one from the X and we take only that particular, or if there's any other one that also has polynomial feature, or it doesn't matter, we just train everything with the linear one?
Yeah, the features that are not important, or the features that are not related, you won't be using them. You will be just
All
using the
right.
feature that are important. That is why, and also that is covered in the PCA, right? Principal component analysis, like how you reduce your number of columns and all. If you will go back again.
So if you kind of want to use, so PCA, I think I've done something about PCA. Okay, that's fine. So we use PCA to reduce the linear regression polynomial features. I think I understand this one. Plot the Hess feature. Then rig regression, yeah. So how do we know if we need to use either rig or lasso? Because this was like, how do we know? So rig is when there's overfitting, and lasso is when there's underfitting. How do we know our model is overfitted or underfitted? How do we know? Is it from the evaluation metrics? What will the evaluation metric tell us to know our model is
Yeah, so
underfitted or
basically,
overfitted?
when your training error, basically, can you tell me like what is the goal? Do we have to reduce the training error, or do we have to reduce the test error? So what is our goal? Can you tell me?
So
Suppose
we're
you are
looking to
getting
reduce.
very highest, very good score for your test test data. Is it a good model? Can you say like this is a very good model?
Yes, of course. If we're getting a good score for our test data, then that's a good model.
Okay, and if it is getting a good, very good accuracy for your training data, is it a good model?
Yes, if it's getting both, it is a good. But if it's getting 1/1, then it is either underfitting or overfitting. So we need to balance it by minimizing the error.
Okay, suppose say you don't know about the test score, right? You are just given the
Yeah.
training score. Can you test say like this is a good score or this is a good model?
No,
Why?
because I've not trained it on the tests on an unseen
Exactly.
data, on an unseen data.
Exactly. So this has to be in a test data, right? So that is why we
Yeah.
do this thing. Basically, the motive is to do the accuracy, find the accuracy on the test data.
So my issue is,
And
for
if
example, when
yeah,
I
so
kind
yeah,
of
so
do the
that is what
RMC,
yeah. So just a second. So that is what I'm trying to tell you. Like that is how we find that there is a overfitting when your test data is very less and training data is very highly accurate. Right? You're getting very good score for your training data, but you're getting low score for your testing data. That is your overfitting. Yeah. Now, Sim.
yeah, I understand, but how do I interpret it? For example, because if I'm going to test my training data, I will be seeing R2 score is 0.793, RMSC is 3.00, and my, let's say maybe my test is having something like this. How do I know, how do I interpret it that R2 score, if it's lower, RMC, if it's higher, it means overfitting, but if it's lower on test and that sort of thing, that's what I don't understand.
Mm, I didn't get you actually. What your doubt is?
I'm saying I don't have it here, but how do I interpret the test? Okay, yeah. For example, look at this now. Using polynomial, the train. This is us training, and this is this is us training using polynomial feature, the linear regression. Then look at so the how to score for
Hmm.
the how do we see the how to score for the test? How do we see the score for the test? For the train, sorry. Because we can see that for the test, this is how to score for test poly and widespread poly, which is for the test. Where do we see the training scores to compare the training and the tests? That's where I'm going to. So because I can see these are the test scores. This is how the model performed on the test data. But on the training data, how do I see what how the model has performed to be able to compare? I don't know if you understand what I'm trying to say.
Mm. This you want for your check whether it is overfitting or not, is it?
Yes, yes. Because look at this one now. You're only showing me, I'm only seeing how the model has performed on the test data. I'm not really sure how the model has performed on the training data to kind of see if it's overfitted, to compare it to the test data, to kind of see if the model is
If you
performing
just
well on
use this
trains and
function,
not.
so can you tell me like how we are getting this R2 score? We are using this R2 score function, right? R2 underscore score
Yeah,
function. So if
yeah,
you just use
yeah,
this for training features and you just pass there the training features, basically the X train poly transform and Y train poly. So then you will get the R2 score for your training data. Right now you have passed the test values, right? If you pass there the training value, you will get the values, the score for your training data.
sorry, I don't understand. I won't lie.
So here,
I think
here,
I'm confused on this part. That,
okay. So see
or
here.
let me just go to normal
No, no,
regression.
that is fine. That is
Let me
fine.
just go to normal regression.
Uh,
Huh?
yeah. Okay. So this is also fine. So here, if you will see this R2 underscore score, right? This function, the second last line
Yeah, yeah,
above this in the code,
yeah. This one.
in your
This
code,
one, you mean?
in no, no, in your code, where you have print statement.
Where?
Your second last line. Yeah.
Oh,
This.
where my trains?
No, no, no. Come down. Come down.
This one.
One line more. Yes, this. Here
This one.
you have passed. Yes. Here you have passed Y test trig and Y pred, right? In
Yeah,
the R2 score function. So R2 score function is basically it will give you the R2 score, right? And in place of
yeah.
X test, sorry, Y test and Y pred, if you pass the Y train and Y, uh, right? That if you pass the training features there, so it will give you the R2 score for your training variables. That's it. So right now you are printing it for just for test.
Okay,
You have to just replace the input value.
okay. Yeah, that is what I'm expecting because I want to be able to see what. has happened to my train to compare that, okay. So, because if I'm only getting the test, how do I know how the model has performed on the train and on the test? And how do I even interpret this? What does 0.95 mean? What does 1.577 mean? So, I think what I'm just going to do is, so you're saying if I'm going to do for this, for the training, then I'm just going to, um, so how to score Y test. So this will be, what would this be if I'm going to do for the train? Is it Y S train?
Hmm.
Hello. So
Yeah,
this will be S train. S train.
correct. Yes. Make sure that you have those features above. Yes, you have that above. So if you will do
Yeah, S
this,
train.
yeah,
And
yeah.
so this one will be Y. Will this be Y pred also or Y train?
For your training, it should be for your training. Just make sure that the column name are correct. Just match them.
What would I replace this to?
Y bread len, your train, Y train, X train. Wait, train. This should work. No, no, this will not work. Train, Y train, X train, Y train. I think here you will be. It should be. Wait. So for now, for
Because
this, you
that's
have
where
to
it's
see.
confusing me that.
Yes. So if you're getting confused, just do one thing. Just you can print the number of rows there. You will find that number of rows for test is way less than the number of train. So that is how you can identify that which variable have the training or which variable have the testing features. So that is how you can identify it, and you will not get confused. You can do this later.
Yeah,
Just see like which are the other values are of the training and other are for your testing, and just use for the
I think
testing.
what I'm confused about is what I'm confused about. How do I know that my okay? I think what I'm going to do is that's fine. I will do a research on it, and if I don't understand, I will come back to you because I'm looking at all these things, and one thing I can see is just the test
Hmm.
evaluation result. I don't know what has happened during the train. I don't know how to compare to know if there's overfitting or there's underfitting. How do I understand? For logistic regression, I can still understand. For example, now, just looking for the one I was. For logistic regression, I can kind of, I still kind of, there's nowhere. There's no. I still kind of understand. So this one is loan approval. Sorry, I'm just finding. I still kind of understand what I'm doing. But for this one, it's a bit confusing.
Okay, no worries. You can just
Yeah, for logistic
later.
regression,
Yeah,
I
go
use.
ahead. Just you can skip to other concepts, or you can see that later if you want.
All right, that's fine. That's fine. Is there
Just
anything
give me a quick
else you want to share?
overview of other concepts are there that you have looked.
All right. Say that again.
Yeah, go ahead. Like now you can continue like which other concept that you were showing, like wherever you have worked upon.
Yeah, it's this one, but I think this I possibly understand classification because with classification I can just use confusion metrics to see how my model has performed, how my model has predicted right. But with regression, I'm not able to kind of interpret my results. With confusion metrics, I can write code to kind of look at the precision, the recall, look at the F1 score, look at, for example, now I tried two model here. I tried SG Boost and random forest. I think this is random forest. Let me see.
Okay, no worries. So you are
SG
fine with
Boost.
now this classification models, right? Now you have some doubt in the regression models.
Yeah.
Yeah, so
But
that's
if there's
good.
still more classification models that I need to know.
Right. So that is what like we are going to do cover next, like some of the class regression model, and again when those models should be used, and some intuition behind them. That's why I think for today, like now
Yeah.
the
And
time
I
is
want
up
to
around,
interpolate and
and
interpret the foundation.
yeah, repeat.
Yeah. Yeah, that's fine.
So we'll do that, and yeah, so let's try to catch again like tomorrow around the same time. Just ping me, and we will
All
be
right.
starting the show session. And also, we will start the project also on the parallel, so that you are on the good
Right.
timeline, and you just complete the core project by the end of this month, or at least the start of the next month. Okay.
Just to confirm, is the project just classification or classification and regression?
It will include complete deployment and everything, the front end, your API integration and all. So it will be very practical. It will be very relevant, and it will be very relevant to the industry. I will also try to implement the LLM part there.
Yeah.
And so I will just share you the some assignments that you can look
Yeah.
up, and you can try them on your own. So in that project, like most of the
Okay.
tasks will be on your side. So you have to be very active for that, and you have to be very you will need to give some time in that thing.
Yeah, yeah, I'm ready. The thing is, I want us to start the project because I'm going to be 3 weeks off from the 16th. I'm going to be off from work for three
Sure,
weeks. So if we could start the project by next week, get everything all set. Because I feel like I've not done about
sure,
NLP, natural language
sure,
process, but
sure.
that's fine. I think just machine learning, if I
Right,
could confirm,
right,
using all this polynomial regression, read,
right. So NLP and all those stuff
lasso.
again come under your LLM stuff. So LLM is like a more advanced stuff of your NLP. So I will try to bring that in the your project, and I will give you the tasks, assignments, and all, and that you have to just
Yeah,
deliver them on time, and you will be
yeah,
having a good solid project that you can use for your showcase.
yeah,
So just do
yeah.
this, and probably like from next week, if everything in the everything there we have completed, or we will start the project thing, and just be prepared for that.
All right, that's fine.
Yeah. Okay, cool.
All right.
Yeah.
Fine.